This is our first video for Unit 2. Unit 2 is all about comparing groups, as well as a great introduction to the normal model. So we first want to look at comparing groups with histograms, and we're going to look at this example on cloud seeding. So cloud seeding is an attempt to alter the type and volume of precipitation by dispersing substances in the air that serve as ice nuclei. So essentially, they put particles in the air that can be the center of an ice pellet. Seeding clouds may help to increase rain production in areas where water is not readily available. So the histogram on the right shows the volume of precipitation in liters from both seeded and unseeded clouds. So the problem with this histogram is that I have absolutely no idea, is this a seeded cloud? Or is this a seeded cloud, or is there a little bit of both in each one? So this histogram is fairly useless to me at this point. However, if I am able to take the two data sets and notice I want to put them on the same scale, so it's not copied over, but we can see that the two histograms both have the same scale, and that is the most important thing when you're comparing two groups. It's obviously a lot easier for me to compare these groups now. So now when I'm comparing groups, I can look at the shape, center of spread of seeded clouds and the shape, center, and spread of unseeded clouds, and then compare them. So if I look at the unseeded clouds, which is the top graph up here, I can see that it's skewed right because obviously we have a tail over here, and therefore it is skewed right. The median or middle is somewhere between 0 and 400, so it's in here somewhere. The maximum volume of precipitation is near 1200, so we can see that this is the max, which is about 1200, but the majority of our data is here at the 0 to 400 range. Looking at the seeded clouds, I can tell right away that I've got an outlier over here. It's still skewed right, but I definitely have an outlier at 2800 liters. The mode appears to be in the same place, but notice that mode is not as high. So I can talk a little bit about the variation and how there is less variation with unseeded clouds because most of them are in that 0 to 400 range. Again, the median appears to be somewhere here. The middle appears to be somewhere between 400 and 800. Here's a question for you to try on your own. So press pause, try this question, and then press play to see how you did. So looking at these two histograms, we have the heights of 100 US women, and that's on the left, and then we have the heights of 100 European women, and that's on the right. And we're trying to compare the distributions, and some things that we might look at, we could say they're both unimodal and roughly symmetric. Again, we're saying if I drew a curve, they both look like I could cut them roughly in half down the middle, and it would be about the same on each side. They only have one mode. Each distribution appears to be centered around 164, so now we're looking at the center. I would say this one, the center, looks to be about right here, which is 164 or somewhere between maybe 162. Here I might say the center is 164. I would talk a little bit though about the variation because the US heights appear to be more spread out than the European women, and by that I mean I've got some higher bars on each side here, whereas it seems to have a much more clear pattern dealing with European women.